Right, projectile motion, that's motion in two dimensions, the x direction and the y direction. Now you have the initial velocity in the x direction is u cos theta according to the diagram there. U is at an angle of theta to the horizontal. Now the initial velocity in the y direction will be u sine theta. The final velocity Vx on the x direction is the same as the initial velocity, because in the x direction there are no other forces that act on it, so it moves at a constant speed, so no acceleration. Whereas in the y direction we have Vy is equal to uy plus gt, because acceleration is g in the y direction. Now the time taken in the x direction is the same as the time taken in the y direction. The acceleration is 0 in the x direction. Acceleration is g in the y direction. The distance covered in the x direction is called the range, which is the horizontal velocity times the time, which is equal to u cos theta times t. Now the distance traveled in the y direction will be given by ut plus half gt squared, where u is the initial velocity in the y direction is. Now to find the time taken to reach the maximum height, you use v is equal to u plus at, where the u is in the y direction. Now you get u sine theta over g. The total time of flight will be twice that, which will be 2u sine theta over g. Now to get the total range, it will be u cos theta, which is the component in the x direction, times the time which you've just found, which is 2u sine theta over g, which then gives you 2u squared sine theta cos theta over g. Now there's an identity in mathematics which says that sine 2 theta is equal to 2 sine theta cos theta. Therefore our range now becomes u squared sine 2 theta over g. Now for maximum range, the value of sine 2 theta must be equal to 1. Therefore theta will be equal to 45 degrees. Therefore the value of sine 2 theta, like I said, is 1. Therefore the maximum range will be u squared over g. So if you get that value, that's your maximum range. So in order to launch a projectile for a maximum range, you need to fire it at an angle of 45 degrees.